Hello, everyone. Thank you for joining us today. My name is Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's webcast. We'd like to begin today's program by saying a big thank you to Akamai for sponsoring today's event and let you all know Akamai is the leading provider of cloud services for helping enterprises provide secure, high-performing user experiences on any device anywhere. If you've ever shopped online, downloaded music, watched a web video, or connected to work remotely, you've probably used Akamai's cloud platform. At the core of Akamai solutions is the Akamai Intelligent Platform, providing extensive reach coupled with unmatched reliability, security, visibility, and expertise. Akamai helps enterprises around the world optimize the web experience with SaaS cloud computing solutions, including web application acceleration, mobile commerce optimization, web video streaming, and content delivery network (CDN) services. Akamai's web security solutions protect online assets against threats such as SQL injection and DDoS attacks for maximum information security. Akamai removes the complexities of connecting the increasingly mobile world, supporting 24/7 consumer demand and enabling enterprises to securely leverage the cloud. Thank you again, Akamai. All right, folks, as we get the event started, I would like to introduce you to Guy Podjarny. He is from Akamai, and he is a web performance researcher, evangelist, and Akamai's web CTO, focusing primarily on mobile and front-end performance. As a researcher, Guy frequently runs large-scale tests, exploring performance in the real world and matching it to how browsers behave, and was one of the first to highlight the performance implications of responsive web design. Guy is the author of Responsive and Fast, Implementing High-Performance Responsive Design. We will be providing you all details during the event today on how you can get your copy. Guy is also the creator of MobiTest, a free mobile measurement tool, and contributes to various open source tools. Guy was previously the co-founder and CTO of Blaze.io, acquired by Akamai in 2012. Folks, we're really excited to have Guy with us today to present this webcast for you all. All right, just let's go over a little housekeeping to help you get the most out of today's webcast. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Guy. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Guy, please preface them with a capital letter Q so we know that they're for him and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you'd like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is VelocityConf, all one word. If you have any trouble with the webcast, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. Folks, we are recording today's webcast and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Guy for his presentation. Hello, Guy.
Hey, Yasmina. Thank you. So hi, everybody. Thanks for joining us today. My name is Guy Podjarny, and I'm the CTO of the Akamai's Web Experience Business Unit. So today, I'm here to talk to you about the performance of responsive web design and the implications of it. But to do so, we do need to set the ground a little bit and talk a little bit about background before we dig in. So first of all, we're all here because mobile matters, and there are a gazillion stats that I could probably choose from here. This is just one stat from Kleiner Perkins showing the growth in mobile usage as a percentage of web usage, just how much of the browsing today is done via mobile devices. And you can easily see that pretty much across the world, the pace of growth is staggering, with the percentage of traffic coming from mobile devices doubling in pretty much any region of the world and globally, and in some cases reaching as high as 38%, especially in Asia and Africa. So very, very high stats. And therefore, mobile is clearly something that nobody can ignore today. Historically, the very first solution that we've done when mobile was introduced, maybe arguably when the iPhone was introduced, was effectively to do nothing. Right? So a user would browse in, and regardless of the incoming devices, they would always browse the same URL. They would browse www.foo.com. They would be routed in slightly different ways, but eventually they would get to a desktop origin, regardless of which network or device they came from. And this is still a very, very popular approach today, as in a non-approach. I don't do anything really about it. And as probably most of you are aware, it's not ideal. The core challenge is that these desktop pages simply don't work on mobile devices, and namely on smartphones, on smaller mobile devices. The interaction with them is bad. Granted, you can pinch and zoom and navigate and pan around the device, but that still doesn't give you everything, and is often just unpleasant to work with. From a performance perspective, the pages are just too big. Today, an average desktop page, I think the average has just surpassed 1.8 megabytes, and that's just a lot of data, and it takes a long time to download that type of content onto a mobile device, especially over cellular. That's the network performance component of it, but at the same time, the pages were just too complex, and that led to functionality issues around especially mobile browsers or the long tail of mobile browsers that may not support various features, and oftentimes processing issues around digesting the page. Today, when you look at stats, if you use a more detailed mobile performance testing tool, you would see that on mobile devices, oftentimes 30 or even 40% of the time is actually spent processing the page. Easily 10% of the time could be spent simply parsing JavaScript. So we'll talk about that a little bit more later on, but clearly those were challenges. If this is the stick that's tried to make people do something or make organizations do something about mobile, there was also a carrot, and the carrot was the value of performance. Over the last few years, we've seen many, many different stats that show real user behavior using navigation timing, information from the browser around how long it takes to load pages, and correlating that to business metrics. On the left, you can see a couple of stats from eBay and Walmart that show clear correlation between page load time and conversion, the actual amount of shopping. And on the right, you will see stats that are more interaction stats. So those are aggregated stats, and they show bounce rate and the number of pages per sessions. Those are common metrics for user engagement on a page, and you can see how they scale up as page load time decreases. They basically get better as the page is faster. And so, as you probably, or you may be doing already today, many organizations are doing something about it. And up until the last couple of years, really, the pretty much only approach that was taken was dedicated websites. We're also often familiar with these as an M.dot site, a mobile site, but they're often tablet-specific websites, T.dot sites. In Japan, there's actually a separation between the S.dot, which is for smartphone, and the M.dot, which is more for feature phones. And generally, those are implemented as redirects. So every time the user on a mobile device has to go back to the desktop origin, so to the origin serving the www website, get redirected back, and then go off to a different server, which is the mobile device. Certain performance optimizations can accelerate that a little bit. Maybe you can get to the edge server, to the content delivery network, the CDN edge, like the one like Akamai's CDN edge, and that one would be closer to the user, so the redirect would be a little bit faster, or maybe a lot faster, but it's still there. It still requires time, and you still need to be bounced off to a different location. But still, eventually, you got a website that was tuned for mobile devices and was light. And as a result, those websites, maybe this is not entirely intentional, but those websites, the mobile-specific websites, are often smaller in content, smaller in functionality. They show less, they have less screen real estate, and therefore they show fewer images, just less visuals. And that results in the pages being smaller. Again, I'm not sure this was intentional, but it is definitely a repetitive theme. If you look at the average sizes for, or average characteristics of a mobile page, an M.dot page versus just desktop, you can clearly see that both the number of bytes, the page size, and the number of requests made to load the page are dramatically smaller on an M.dot site than they are on a desktop-oriented website. We're talking 3 times smaller. So that is a huge difference, and it helps, although we still complain about performance on mobile devices being slow. This type of gap in the amount of interaction, amount of processing, and sheer amount of data that needs to be downloaded makes a world of difference in how fast and usable our websites are, especially when the user is on a congested network. But still, as you know, the reason that we're here is talk about responsive design. Clearly, mobile or dedicated mobile websites were not good enough, and they really had a few challenges with them. Let's talk about a couple. The first one was that redirect time is expensive. This is a visual from one example on the ESPN website showing how a couple of redirects, one mobile related and one application related, took 2.5 seconds, which was a clean 23% of the overall page load time. So this is a nice and light page oriented at mobile devices. However, another 23% of the time is taken away just by redirecting and bouncing over to the correct website. So redirects are expensive, and they take away from that smallness, from that speedy nature of those small dedicated websites. The second challenge that is often discussed is that of sharing those URLs. So what happens if somebody is on a mobile device, has seen an interesting article, now takes that link and shares it over Facebook, over Twitter. Somebody else now on a desktop opens up that link and suddenly gets the mobile experience on desktop. So that's clearly not an ideal experience. I'm sure many of you have experienced it before. And that led to the first requirement that we have with regards to responsive web design. And again, bear with me as I do this background. It matters when we talk about the responsive design and what should we compare its performance to. So the first challenge we had was around serving everything on a single URL. And the solution to that is often referred to as adaptive delivery. It's not quite as well defined as responsive design, but adaptive delivery is the dominant term. And the notion here is you maintain a single URL, so you always have a www.something URL, regardless of whether this is a mobile device or a desktop device. However, at some point in your delivery decision, you decide to route the user to a different origin. So in this case, you might be using the CDN Edge, and you get the request, and depending on the incoming devices, you choose whether to go to a mobile origin or to a desktop origin and serve a different content. These are still dedicated websites. This is still a website specific to a mobile device or a website specific to bigger screens. And yet, they are delivered over the same URL, therefore alleviating the need for redirects and allowing for easier sharing of those URLs. So both on the functionality and on the performance side, those are improvements. But of course, we didn't stop there. This tackled one of the problems, but there was another problem that we didn't discuss before, and that is detecting mobile devices. So, and in general, the notion of what is mobile. So when we look, this is one of the visuals that I like the most. It's from OpenSignal, and it shows the market share of different devices using their apps. And this is only on Android. Things get actually nastier when you go broader. And what you can see here is every block represents a different, a bigger market share. The bigger the block, the bigger the market share, but represents a different device. And it's not really about which device is in the lead, but rather just the sheer amount of devices. We see over 7,000 different device types every day on Akamai. And in fact, I believe the stat is more than 8,000 today. So clearly detecting mobile devices is hard. Now, you could use technologies that help identify those devices for you. There are technologies like Whirlpool, Device Atlas. Akamai itself has EDC, Edge Device Characterization. So that helps because we identify those different mobile devices and we sort of simplify them. We layer these blocks of metadata on top of them. So suddenly you can make business decisions based on this is a smartphone, this is a tablet, this is a feature phone. But it doesn't quite end there, because even that sheer distinction of saying what is a smartphone, what is a tablet, even those decisions get very hard, Today we have all these different devices. The same devices can be used in landscape and portrait mode. We have new devices like the Pebble or Google Glass coming in. We have these watches getting into the mix now. We have this world of devices, and this classification, this categorization of a device as a smartphone, as a tablet gets harder. Right? What makes a phone that is 5.5 inch has a 5.5-inch screen, a phone, and 7-inch a tablet? I mean, who drew those lines, and what does that really mean for the experience that you want to give on this device? And of course, this gets us to the starting point of our technology we're talking about today, which is responsive web design. This is a different approach, and it says, let's have a single URL, but let's not stop at a single URL, but rather have a single HTML response, a single response that actually gets sent back and adapts on the client. And this theme, this notion of adapting on the client, not classifying, not identifying maybe even the device, but rather sending a single piece of content that can always adapt on the client, is a core theme in how responsive design comes to be, and its strength, its power. Although at the same time, it's also, as we'll soon see, one of its pitfalls with regards to performance. So we have many different responsive websites out there today. This is definitely a growing trend. And it's probably helped to a certain extent by the fact that Google is recommending responsive web design. They explicitly point out, talking about dedicated websites in number 3 here, talking about adaptive delivery in number 2, and talking about serving the same HTML to all devices in number 1, stating this is Google's recommended configuration. We all fear the voodoo of how Google ranks websites, but we definitely all care about it. So between the technology value, the ability to be future-friendly, to be ready for devices that have not yet been maybe hit the market, and of course Google's recommendation, definitely the adoption of responsive design is great. But not everything is great. When we talk about performance, there's definitely a big difference between responsive design between responsively designed websites and dedicated mobile websites. But before we go there, let's talk a little bit about the good parts. So if we look at responsive web design and compare it to desktop websites, we will see that the responsive websites are actually smaller. This chart is actually a little bit misleading because the delta is not really as big as the graph makes it appear. It actually goes from about 1.6 megabytes to around 1.5. So it's not a huge drop, but still, when you look at responsive websites and you compare them to the average desktop websites, you do see the responsive websites are a little bit smaller. This is based on the analysis of the top 5,000 websites, and it's fairly consistent. It's not entirely clear why that is. It may be that the websites that are responsively designed are just designed by slightly more skilled teams. It may be that those websites are a little newer. But this is a pretty consistent stat that you can see. So responsive design does introduce a certain knowledge, a certain cleanliness that eventually drives smaller pages. However, when you compare responsive websites to mobile, the picture looks very, very different. So this chart shows the page weight across desktop pages, responsive pages, and M-dot sites. And what you can see here is that the delta between the M-dot and the responsive remains pretty much the same as it was in the original chart we showed around M-dot versus desktop site. In other words, responsive websites are almost 3 times as heavy as dedicated mobile websites. And it's pretty obvious that that would incur performance penalties. We'll talk about that more in a moment. So these are averages, and averages tend to lie. If you look at distribution, we see things that are fairly similar. What we can see is that only if you look at the top 100,000 websites, so this is a bigger test set, we can see that only 7% of websites were at least half the size when served to a small screen versus serving it to a big screen. They very much looked like a dedicated website on a small screen and very much looked like a full, large, rich desktop site on a large screen, and yet they were much, much smaller, only in 7% of the cases. About 30% of websites were between 50 and 90% of the size between the small screen and the big screen. In other words, 30% of the websites were slightly smaller on a small screen. And the vast majority, 2/3 of the websites, were pretty much the same size, regardless of what the screen size is. So this, when you go in and you drill into any anecdote, basically demonstrates that practically every website, responsive website out there, the vast majority of them, have not really taken care of performance considerations, have not really tried to tap into the fact that on a small screen, on an M-dot like experience, you're showing less, and therefore you should be consuming less data. You should be faster. This is a challenge, and as we mentioned before, not only is it a challenge overall, I mean, a 2 megabyte page is going to be generally slower than a 500 kilobytes page, regardless of your network condition, but it's especially bad when you're talking about poor cellular conditions. This is a chart that shows latency and average download times across 3G, 4G, Wi-Fi, and cable, just normal Wi-Fi capabilities. And those are averages in the UK, and they are really huge differences between 4G and 3G, and then of course between 4G and the cable connections that we have. This gets even worse when you're talking about congestion and when you're talking about low reception areas. Definitely cellular makes this gap in page size even worse than it would be. So, okay, so we've established responsive websites are bigger than dedicated mobile websites. Let's dig a little bit into why so we can actually fix that. This is an example of the Chanel website, just one of the responsive websites that I decided to pick on. And in general, I will say that I mentioned various examples throughout this presentation of specific sites that are doing something well or wrong. Those are all just examples. I really could choose many, many of them. It's not that these specific websites are doing something especially wrong. On the left, you can see the mobile view of this page. It's actually the lower half of the page. And on the right, you can see the desktop or the big screen view. And you can see there's these two thumbnails around Inside Chanel and Chanel News that don't show up in the small screen version. And that is done in the traditional responsive design way using a media query, which you can see at the bottom, that says max width 640 pixels and min width 1 pixel. And basically, if the screen is not big enough, if it's less than 640 pixels wide, these images are hidden using a style display none. This is the client-side decision logic that we mentioned before, and it's basically how responsive web design is implemented. It has display none for hidden components. It has some percentages we'll talk about in the rest, but for the most part, it uses styles. However, if we look at the network view of loading those pages, you would see something that you might not expect. At the top, we still see that same CSS, but if you look at the network view, you can see that even in the small screen view, when we load this page, those two images are still being downloaded. And in fact, in this case, they're not that small. They're 160 and 180 kilobytes in size. That is 320 kilobytes of data that needs to be downloaded unnecessarily, and that's just these two images. And the reason for that is that styles, any style, don't really affect the downloading of resources on a browser. Styles are layers about how to lay out your content, how to style, how to present it or not to present it. But they're usually applied later on in the process of loading a web page. And they, I think, pretty much always, if maybe there are a few exceptions to it, styles do not affect the downloading of resources. And as a result, these images are downloaded if you hide them. Same would happen if you move them off screen or if you shrink their size to be 0 by 0, 1 by 1. Neither of those style effects would actually make those images not be downloaded. There are some slight exceptions with regards to background images. So if you have some nested divs and with background images, some specific conditions, background images may on occasion not be downloaded. But for all of these foreground images, for these usual images on a page, pretty much without exception, those images will be downloaded regardless of how they're styled. So this, I often refer to this type of problem as a download and hide problem. There's also another version which is more download and shrink. This is an example of the Microsoft homepage. And again, you see an image here. And in this case, in the big screen, you see the image as a big image. And on the small screen, you see it as small. And again, this is a core tenet of responsive web design, the notion of fluid images, the notion that images are a percentage of the screen width or the containing element. And once again, those are styled. So both of those images, although they look differently, they actually point to the same URL. They're downloading the same amount of data. However, clearly the image that is smaller could have been communicated with less data. In fact, that's exactly what we do on these those dedicated sites. In fact, Tim Kadlec has done an analysis. Tim Kadlec is a very smart individual doing a lot of mobile design and development and consulting, and he's done an analysis and showed that on a small screen you can on average save 3/4 of your image bytes just by resizing them to the display size. That's a huge amount. So between download and hide and download and shrink, there are just volumes of data that are unnecessary and are being downloaded to our browsers. Definitely not desirable. So one last example on images before I veer off, which is today there's a new model or a model that is increasing in popularity, which is to have an image and have the same image show on two views, but basically crop it using styles. So only show a portion of the image on a smaller screen, and maybe show the full picture on a big screen. So once again, this is done using CSS, using styles, and once again, and you can probably detect a repeating theme here, that does not affect the downloading. So this is an example on the android.com website, and again, you can see this beautiful image with different devices that is very elegantly sized to the screen by just cropping and focusing on the center. However, it doesn't help the data download, and in both cases, the entire devices.jpg image will be downloaded. So those were images, and I focused on images for a reason. Images account for anywhere between 60 and 70% of page bytes on pretty much any page today, and they are the primary reason, they're the primary source for this excessive downloads that we see on responsive website. However, it doesn't end there. The next example I want to show is JavaScript. So this is a slightly loaded slide, so I'll kind of narrate the different portions of it. On the top left, you can see the small screen and then the big screen version of the Smashing Magazine website, a very popular web development magazine. And on the big screen version, you will notice that there's this big ads banner on the right, and also on the left you might notice, I kind of blew it up, some social sharing buttons. So those are the components you see on the right of this slide. Those are components that are heavily JavaScript oriented. Some of them are purely generated by JavaScript, some of them are driven by JavaScript. Same goes for that Smashing newsletter, which has a little bit of JavaScript in it. And yet, when you look at the number of JavaScript requests and bytes on a small and large screen version of this site, once again, as before, you will notice that pretty much the same number of requests and bytes are being done. And some weird coincidence here, it looks like there are actually more JavaScript requests and bytes on the small screen version here, which is probably just a fluctuation of the page. But there's definitely not less. There's definitely not no reduction, despite the fact that those pieces of JavaScript generate content that is unused on this screen. So this gets us to another aspect, which is resources on the page. Just like with images and the fact that styles don't prevent the downloading of the page, the same thing goes to JavaScript and CSS. JavaScript and CSS that is loaded on the page will be processed by the browser pretty much regardless of what the end result is styled as. In this case, it's even harder to do because harder to really argue with that because the browser doesn't really know what a script would generate, and the browser doesn't really know what a CSS would apply to until it actually processes and parses those components. So with that, those are examples of the reasons for over-downloading. We talked about images with various varieties. We talked about JavaScript. And while I didn't show an example, the same thing happens with CSS. So there are two conceptual solutions to this. Those were the problem. This is the core problem, over-downloading. There are two conceptual solutions. The first one that I'll spend the bulk of the time on is called conditional loading. So arguably all of the functionality in responsive design is already conditional processing or conditional styling, right? We literally have conditions in these media queries that say, if the screen is greater than X, then make something visible or make something invisible. However, we don't have conditional loading in the browser. Those things style resources differently, but they don't actually affect the loading of those resources. So what we need to do is we need to add this layer of conditional loading to our front end to complement the way the browsers work. Today, browsers don't really offer us native conditional loading. Hopefully that would come in the future, but today they don't offer that. So we need to layer on this conditional loading concept into our JavaScript. Let's look at a couple of examples of this. So this is a simple example of a conditional loader of images. This is a very simple example, and it only tackles the hidden images component. It doesn't tackle the download and shrink problem. At the bottom, you will see an image tag, but in the source attribute, it just points to this 1x1 pixel GIF, and only in the data-source, it holds book.jpg, which is the real image that you want to load in this case. What we've done is we've also added to this image tag an onload event, which calls a function, a method called loadReal. This method, as you can see at the top of this example, checks if the image is hidden or not. And if it is hidden, if it is not hidden, it deletes the onload event just to avoid repetitive calls, and it copies the data source attribute into the source attribute. So in other words, what we're doing here is we're always loading this 1x1 pixel image, which is going to be the same 1x1 pixel image across the entire page, so not a lot of weight here. And then we store this metadata in easy markup on our page, and we load that with JavaScript only if our conditions are met. In this case, the condition is very straightforward. Is the display none? However, in the real world, displays need to be, or the conditions need to be a little bit more elaborate. Here's a slightly more elaborate version. In this case, we use a library called imager.js. This is a library that was released by the BBC News team and that they used on their own website. And basically what it does is it also adds the notion of available widths and available pixel ratios as parameters to say, I also need to resize my screen using these definitions, these parameters around the breakpoints, if you will, of device widths and device pixel ratios, the notion of a retina screen. And then if you look at the top, you would notice that the data-source attribute has a width variable there. It has these curly brackets, and inside there's the width. And the imager.js library would go off, find those attributes, replace the width attribute with the appropriate number depending on the current screen conditions, and then issue this request. So imager.js is a great way to make the client side a little bit smarter and support, also tackle the download and shrink problem. However, notice that it does use another component here, which is it assumes there's a server-side component that would generate the image on the fly. So it assumes that there would be this server side that can take this book.jpg with the resize argument and resize it based on the instructions just given. So these types of image transcoding services are gaining in popularity, and I think are very, very helpful when you start dealing with multiple variants, multiple views of the same image. This notion of managing your images is becoming more complex, and it's something you really should be paying attention to and build a strategy a little bit around that when you decide to tackle images in responsive design. In this case, I'm using Akamai Image Converter. In the BBC example, they have actually built something in-house called Image Chef that they're using for that. So whatever solution that you're using is fine, but I would very much recommend using an image transcoding proxy to modify or to be able to generate those images on demand. So in reality, even imager.js is not quite sophisticated enough. When you get into the real-world details, you have cases where you might want to show a different portion of the image on a different screen. We've seen that with the Android example, right, where we had client-side CSS-based cropping. We don't want to do this CSS cropping because we don't want the excessive downloads, but we do want the crop. So suddenly you want the ability to do the actual cropping on the server. This is often referred to as the art direction because it's more about the design decision. It's more of an artistic decision than a performance one. And there are also other characteristics. So the responsive images community group is a group that was driven by a lot of different designers and developers in this world to try and push some of this functionality into browsers and have more native support for this. Save us the need to create these JavaScript hacks to load images conditionally and have something that is more native in the browser. There are 3 popular standards that are sort of being proposed by different groups. The picture element and the SRC set attributes are the ones that are most popular, and they interact fairly well. And there's also a slightly different proposition called client hints that is driven by Ilya Grigorik from Google that just moves a little bit. It's more about making the client communicate to the server what are the current screen display properties, what's the width, what is the device pixel ratio, to help the server, possibly using an image transcoding service, generate the right image and serve it down. So I'm not going to go into too much detail about each of those propositions. I would encourage you to go to responsiveimages.org, where you can read a lot of information about them. SRC set is now actually started showing up in browsers, and the picture element is in pretty decent phases of having prototypes being in Chrome Canary and Firefox Aurora, which are the beta versions of those two browsers. So those examples so far dealt with images, and images are a little simpler because they are just simpler elements on the page. You can unhide them or hide them whenever you want, or change their attributes. Scripts are a little bit trickier, but conceptually, conditional loading of scripts is pretty much the same. If you look at this example from the top down, you will see you have a couple of script tags. They have, once again, a media query. So in this case, we are using a media query to indicate when to load this page. And it has a data-source attribute instead of a source attribute. This is very, very similar to what we saw with the image conditional loading. So I just have two examples of those scripts here. And then we have a little bit of script that goes off, iterates, finds all of those objects that have this data attribute. And if the media query matched, then applies the script. In this case, in order to generate the script, you need to actually create a script element, a new script element with the source attribute, but those are technicalities. The concept of conditional loading is the same. And in fact, one project I ran into more recently that I'm quite fond of is the notion of responsive HTML using responsive comments. So in this case, you can go even further. If the images and the scripts were very specific to images and scripts, responsive comments actually suggests that you take any chunk of HTML that you want, you create a div element that has the, again, the media query conditions about when to apply it, and then inside that you use an HTML comment, like the one that we see here, to put any HTML that you want. And then the responsive comments JavaScript library would go off, match the conditions, and convert that HTML into content on the page. So as you can see, you can conditionally load effectively any part of the page. There are some costs to that, there are some complexities to that, but they definitely are outweighed by the value that you get from not over-downloading resources on the page. It's worth noting that when you talk about making the client side smarter, when you talk about making loading resources using JavaScript instead of loading them natively in the browser, you are opening yourself. You're taking control on some components, but it also means that you're taking some ownership and you're veering away from some of the optimizations that browsers may do for you. So you should be aware that the more conditional loading you do, the more you should generally look around at the performance attributes of the rest of your page. This is a bit of a pitch for the Akamai Ion front-end optimization component that applies conditional loading and various other optimizations. But it's also just meant to be a list to show how many different optimizations and different performance pitfalls you might find yourself interacting with or might get in your way as you make your page more complex and you tack on these sort of smarter loaders. So just keep that in mind and make sure performance testing is a part of your system. So conditional loading is great, and it's probably the primary way that you should tackle the responsive web design over downloading problem. However, it does introduce this complexity that I mentioned here. I mean, if we look at the HTML size, just the sheer HTML that the browser needs to build for a responsive website versus an M.dot site, we also would again see a pretty big delta, 40 kilobytes versus 26 kilobytes. These may look like small numbers, but this is the actual HTML that the browser needs to load, process, and keep in memory as different DOM elements. the more DOM elements you have, the more memory you have, the slower it would be to modify the DOM, the slower it would be to find something in the DOM. Those are substantial components, especially on a weak device. In addition, we talked about the bytes a lot, but there's also the issue of just the sheer number of resources. If we look at the number of JavaScript and CSS resources on a responsive website versus an M.dot site, again, that same pattern repeats. 8 JavaScripts on an average M.dot site versus 18 pieces of JavaScript on an average responsive website, and so forth and so on and so forth. We definitely see a lot more code, a lot more program being delivered to the browser. And this program takes its toll. Here is a visual of loading Smashing Magazine, that same website that we showed before. And what you can see here is on the right, you can see what happens when you load this page on a desktop machine. This is actually a very weak desktop machine. It's a weak VM. This is done using Web Page Test, which is a great web performance testing tool. And what this little diagram showed is the breakdown of the processing time of loading this page on the browser. So the page is loaded on the browser, and there is a certain amount of compute that is needed for it. So in general, compute on the desktop is really quite negligible. In this case, it was less than 5% of the time. And I want to hone in specifically on the evaluate script option. So the evaluate script is the time it takes to just parse the JavaScript. This is not about running the JavaScript. This is just about parsing the JavaScript and understanding what's in there. On the desktop, that piece took 6.9% of the overall compute time. On a Motorola E device, a semi-weak but still relatively new mobile device, just parsing the JavaScript took 25% of the overall compute time. Just parsing the JavaScript. So even when you do things conditionally, as long as the browser has seen them, as long as it has to process them, those components take up a big portion of time. I don't have the exact stats, but the other aspect here is on the desktop, about 2%, I believe it was less than 5% for sure, of the time it took to load this page was done processing anything on the client. Most of the time was just idle. The browser was waiting for network activity. However, on the Motorola E device, overall, about 22% of the time was spent computing versus idle. That's a pretty substantial difference. And while the Motorola E is not the strongest device on kind of that you would find in our device landscape today, it's also very far from being the weakest. And also Smashing Magazine is really not the most complex website that you would find. So definitely compute and processing time on the browser matters. So if you combine that with my comment before about how conditional loading hinders the browser's ability to process your page, you start thinking that maybe it's better off not doing some of these things on the client. And to do that, you can use a technique called REST, or Responsive Plus Server-Side Components. Not my favorite acronym, but it's the one that's coined in the world today. And the concept here is to slightly mix in maybe adaptive delivery and responsive web design. So let's go with the flow here, or look at the flow. A device would come into the Edge server. In this case, I'm using the Akamai Edge as an example. It doesn't have to be through the Akamai Edge. The Edge detects that this is a mobile device and then sends a request from the Edge to the origin, but adds a little header that says X device mobile. This is a custom header, just indicates to the origin that this is a mobile device. Now the origin sees that, and it can remove, it doesn't know exactly which device this is, but it knows it's not a desktop device. So it can just completely remove the pieces of content from the HTML that are desktop only. For instance, maybe the sidebar there with all the ads and the components. It returns that, and therefore the pages load faster because they are smaller. Of course, if a desktop client comes in, then the Edge would communicate a different X device, and the origin can serve the appropriate page. So this is not entirely responsive, but you can think about this as conditional loading on the server. Just instead of having that condition run on the client, where granted it is the most accurate place, but it's not necessarily the fastest place to run that condition, you can move some of these conditional loading to the server. So a couple of tips on doing this. First of all, you really should focus on removing the portions that matter. You shouldn't really remove any tidbits, any small piece that can just be hidden away but doesn't have a performance implication. Large chunks of HTML like that sidebar, those are probably good candidates. you do want to make sure that your front end remains responsively designed. So you would work with families of devices, and you still want that front end to adapt on the client to work nicely and smoothly on that device. And then lastly is you should tune for families of devices. The intent here is not to say build an optimization that is specific for iPhone 5 running iOS 7, but rather to identify, again, these large chunks of HTML that you can just eliminate. So as a last point on that, to me, responsive REST, responsive plus server-side component, is sort of a combination of adaptive delivery and responsive design. It does say that you should sort of stop being a purist, if you will, and think of responsive design as something that is entirely client-side, and just absorb, adopt some of those best practices that may have happened in the world of adaptive delivery to make your site a little snappier on those popular devices. And REST is technically quite similar to adaptive delivery. In both of those cases, you need some component, be it a load balancer at your origin, or be it a smart web server, or be it an edge server that can identify the incoming device, can route differently, and then can cache correctly. But a very important difference is that REST is a performance optimization, while adaptive delivery is a routing strategy. And what that means is that adaptive delivery forces you to identify and classify every device. So for every device, you need to say, this is mobile versus this is desktop versus this is tablet. And that's really where we fell short before, because some devices just don't fit the profile. However, REST, it's a performance optimizations. If you don't know what this device is, if you're not sure what this device is, just round up. Just go for the richer, for the fuller version of the website and adapt on the client side. It's completely valid, and it might mean that for that devices, performance would not be optimal, but as long as you identify the majority of popular devices in this method, then you're good. You're in a good place. So it's a very important distinction, especially with regards to the maintainability of it. So that's basically it. Let's just summarize what we talked about so far. Dedicated mobile websites are naturally fast. Some of them are terribly slow, depending on how they operate, but they're sort of naturally faster. And adaptive delivery is even faster than a dedicated MDOT sites because there are no redirects components. However, these types of dedicated mobile websites just don't scale because we can't easily classify, or we can't at all sometimes classify, even humans sometimes can't classify a device into these buckets. We can't pretend all of those devices are the same, just too many variables. Responsive web design, on the other hand, is very naturally scalable for this complex landscape of devices, but it's not naturally fast. It can be fast, but it's not naturally so, primarily because a lot of these decisions are made on the client. And to solve that, we have two means. One is we can make those client-side decisions smarter using client-side conditional loading, which today we can pretty much implement using JavaScript. Hopefully soon we would have some standards in browsers that help us do it, or by moving some of those decisions to the server, which is the REST approach. If you do those, you can be responsive and fast. Responsive does not mean slow. It just requires a little bit more effort to make it snappy. That's it. So that's it for this section. I guess next we'll go to Q&A.
Thank you so much, Guy. Folks, you've heard Guy. We are at the Q&A portion now. Please, if you have not opened your group chat widget, open it, type your question in, send it in. We'll take as many as we have time for. And while you're doing that, I also want to let you know you have your resource widget. It's the green file folder widget right next to that group chat. Click on that. You can download a copy of today's slides as well as a copy of Guy's book, Responsive and Fast, Implementing High-Performance Responsive Design. Back to you, Guy.
Thanks, Yasmina. So I'm kind of looking through a little bit of some of the questions that we've had here. So one question is, do you have any tips or recommendations for implementing a responsive framework, i.e. Bootstrap, into an existing desktop-first website versus implementation of a mobile-first from scratch? Well, this is sort of probably a broader responsive web design question, not just about the performance aspect of it. So I wouldn't really tackle the design challenges. There are many complexities around switching to responsive that have to do with your design process and of course your sort of technology, whatever technical debt you have, or your architecture. I will say that from a performance perspective, if you were to retrofit some of the responsiveness onto an existing website, oftentimes it's easier to make the optimization decisions on the server side. So my experience shows that if you are to do this, sometimes just sort of making the server, adding maybe a cookie that indicates the device width and the device pixel ratio, and then having the server automatically resize images in the process. That's one example of moving a decision to the server, maybe doing REST like what I mentioned before, identifying the incoming clients and just removing chunks of JavaScript. The interaction on the front end tends to be a little bit more complex than the changes you need on the back end. So I guess that's my only tip there. Otherwise, definitely not a simple component. One strategy that I've seen work well when you're trying to shift to responsive is to try and build a responsive website for mobile only. So build an m.dot responsive website as your first kind of toe in the water, and then expand from there and eventually replace that original desktop first website. Glancing at a few other questions here. If using media query for hiding DOM elements or images make mobile performance hurt, why are RWT frameworks like Bootstrap or Foundation still being used? So I think there are many aspects to this. So first of all, many of these frameworks are starting to adopt some conditional loading components. Probably the most popular ones is that some of these frameworks have lazy loading of images, so they do the sort of conditional loading of images. I don't think I've seen any framework that does conditional loading of JavaScript built in, but maybe those would come. There are also like WordPress plugins or other add-ons to platforms that do it themselves. So, to a certain extent, it's just a matter of time. The second thought is that there is a cost to doing these types of conditional loads. For instance, if you're loading your images with JavaScript, what if there is no JavaScript support on the browser? So that's not much of a concern, but still in some of these frameworks it may be a concern. Also, as I mentioned before, loading images with JavaScript does mean that the browser doesn't process them. It means you're taking on a little bit more of the ownership. So maybe some of these frameworks just don't have the surrounding optimizations to make sure that if you load your images with JavaScript, that means maybe your DNS resolution would be late or something of that nature. What would happen then? So, I can't really put myself in the mind of the framework authors, but I would say many of these frameworks are building some awareness to responsive performance. That's just relatively new, and some of them might just be waiting for native browser support. So here's a good question about RESS, about REST. Removing content depending on the device is not penalized. Is removing content depending on the device not penalized by Google et al.? So generally, we don't know. What we do know is that various front-end optimizations, as long as the technical changes to the page, Google does not consider those cloaking and does not penalize websites. I also have anecdotal information that I've seen on a couple of specific websites where they've gone to use REST and it did not hurt them. Many of the people at Google are advocating REST, although clearly that's not necessarily proof that the Google ranking algorithm acts accordingly. So I think fundamentally Google tries to mimic the decision logic of users. And as long as the components that you are removing are not the core content of the page, which is probably what you want to be indexing on and what you want to be tracked on, then the going assumption, nobody really knows internally, is that Google would be all for that and would still consider that a responsive website. Can we use .ht access to speed up page loading time? This is an interesting question. So .ht access being the Apache config file or an Apache config directory-specific config file. If I could generalize this question, it says, can you use web server configurations to make responsive websites fast? Definitely yes. Probably the best example is implementing RESS using rewriting of URLs on the server itself. So what you can do, I mentioned in conditional loading that you can, for instance, communicate on the device width and the device pixel ratio. You can do that using cookies. Soon, hopefully, you could be able to do that using client hints. Once the server sees a cookie that has a device width of something or a device pixel ratio of another, let's say you're only treating Retina images, so you're saying what is the device pixel ratio? Is it greater than 1? You can set a condition in Apache and in Nginx and in Varnish and in many of these other configurators that says that if the device pixel ratio is greater than something, then rewrite the URL to go to a different image. So this to me is a form of image res, which means you're using the same URL regardless of which device is approaching you. However, you're setting, let's say, cookies with the device pixel ratio, and therefore the server acts on those and serves a different content. So definitely the mod rewrite and the rewrite module in Nginx and all of these rewriters can definitely be a means to implement that. And I have some more specific examples in the Responsive and Fast book that you should see a link to in the email coming out after this webinar. See, let me just glance through a few questions here. Okay, so somebody asked a question here that talks about saying these look like great solutions, but is this a feature of the current browsers? So I think this is again, if I can generalize the question a little bit, there might be a question that says, shouldn't browsers be doing this stuff? And I think to a certain extent, yes, browsers should allow us to do conditional loading in a more natural way, in a way that is not JavaScript driven. I think in the world of actually, I don't think. What you can see is in the world of images, that is exactly what is happening. Browsers are developing this picture element and the src set attributes, which are literally conditional loading of images. And images are probably the biggest pain point here, so that is a good approach. It would still be, the onus would still be on you to make sure that you use those. And it would still be you, the website owner's responsibility to make sure to generate the different variants of the images to serve them. But at least the JavaScript component will be taken off your hands and would also be made native, and therefore some of the performance penalties that happen from it might not happen. For JavaScript and for CSS, there's some activity going on in this world right now. I don't think anything really to write home about. For CSS specifically, and again, I have some of these examples in the book, you could make sure that you use the media attribute of the link tag. So when you have the link href tag, actually specify the media attribute there as opposed to specifying the media queries inside your CSS. And by doing that, at least you're hinting to the browser to deprioritize that resource, and browsers do support doing that. And that support is even being enhanced with a standard called resource priorities, which supports a lazy load attribute, which marks them as marks those resources as less important than resources that can be deferred. So I think we probably have time for one more question here. Maybe let's take this future one. How do you think RWD conventions we talk about today will evolve over the next 2 years or 5 years? So, future, of course, everything is predictions, based on that individual's, any person's crystal ball. But I think responsive web, so in my opinion right now, responsive web design has been adopted very, very quickly. And because of that, some of the best practices around implementation, around the design process, around many of these aspects have not really been fully digested. Responsive web design is only 3.5, I believe, or maybe it's coming up to its 4 years old, and the adoption of it has really grown rapidly, especially over the last couple of years, out of need, out of necessity, with the complexity of the mobile device landscape. So I would suspect that responsive design as a concept would remain, but I expect more modular loading and more conditional loading of components on the pages that hopefully would just make our pages more sort of API service-oriented, assembled at the browser, assembled at the edge. I would recommend a technology called ESI, Edge Side Includes, which is supported by Varnish and Akamai and various others, and it's a really good example of something where how the future might look like, which is an HTML that includes import components, includes conditional import components. So you might see something that's more of that nature. So I think that basically ran out of time. Yasmina, back to you.
Thank you so much, Guy, for just an outstanding webcast today and for sharing all your knowledge and expertise with us. Thank you.
My pleasure.
Folks that attended our webcast today, we'd like you to thank you for attending today's event, and also thank all of you that sent in your questions, because having your questions really adds so much to our event. We do appreciate it. And many of you, we had people from all over the world joining today. Many of you stayed up late or got up early. We thank you for that as well. Folks, as we close out today's event, I want to remind you, please open that green file folder widget. It's your resource widget. There's a copy of the slides in there as well as a copy to download Guy's book. You don't want to miss that. Lots of great information there that can really help you with your day-to-day. Folks, we'd like to thank Akamai for sponsoring today's webcast and let you all know Akamai is the leading provider of cloud services for helping enterprises provide secure, high-performing user experiences on any device anywhere. If you've ever shopped online, downloaded music, watched a web video, or connected to work remotely, you've probably used Akamai's cloud platform. At the core of Akamai solutions is the Akamai Intelligent Platform, providing extensive reach coupled with unmatched reliability, security, visibility, and expertise. Akamai helps enterprises around the world optimize the web experience with SaaS cloud computing solutions, including web application acceleration, mobile commerce optimization, web video streaming, and content delivery network (CDN) services. Akamai's web security solutions protect online assets against threats such as SQL injection and DDoS attacks for maximum information security. Akamai removes the complexities of connecting the increasingly mobile world, supporting 24/7 consumer demand and enabling enterprises to securely leverage the cloud. Thank you again to Akamai. Folks, we thank you all for joining today and spending your time with us. One more time, Guy, thank you for presenting an outstanding webcast today. Folks, this will conclude today's webcast. Goodbye, everybody.